expand a binomial or two before we do that. So let's say we have x plus y to the 0 power. Well, that's just 1. Okay, and x plus y to the first power, and that's just x plus y. And then when we expand x plus y to the second power, we're going to get x squared plus 2xy plus y squared. That's what we're going to get when we multiply that out. But of course, what happens when you multiply x plus y times x plus y times x plus y, which means x plus y to the third power? Well, you're going to get x to the third plus 3x squared y plus 3xy squared plus y to the third. Okay? You keep doing that. Let's say x plus y to the fourth power. What are you going to get when you do that? That means you're going to take this and you're going to multiply by another x plus y. When you do that, you're going to get x to the fourth plus 4x to the third y plus 6x to the second y to the second plus 4x to x y to the third, and then plus y to the fourth. There's a pattern to this. Okay? Let me show you what the pattern is. Okay? First of all, when you have a fourth power, the first term and last term are the fourth power. And then the powers in the middle, as x, the power on the x goes down, okay, power on the y comes up. At each term, power on the x goes down, the power on the y comes up. Okay, power on the x goes down, and the power on the y comes up. Eventually, the x disappears, and the y ends up being fourth power. So x, you start out with an x, okay, and then x disappears, okay, and then y appears and ends up going to the fourth power. Now the trick is, how do you figure out these numbers in front, the coefficients in the front? That comes from Pascal's triangle. Okay, let me do one more, and let me show you how I'm getting that really fast. Okay, first of all, we know x is going to start out with the fifth power. Okay, how do I figure out my coefficient that goes right here? I just look up, okay, I see a 4, and then I add the coefficient from the previous term, which is 1. So 4 plus 1 is 5. Now x goes down to a 4, and y comes up to the first power. Okay, now go again, because I know my x goes down to a third. Okay, y becomes second now. Okay, how do I get this number? I look up, I see 6, and I add that to the previous coefficient, which is 10. Okay, then I keep going. Okay, and then my x becomes a square, and y becomes the third power. How do I get this number in front of this? I look up, I see a 4, I add to the previous coefficient, which is 6, I'm going to get a 10. Okay, and then I'm going to keep going to the next term. X becomes to the first power, and y is to the fourth. Okay, how do I find this? I'm going to look up, I see a 1, and I add it to the 4, that gives me 5. And then finally, the last one is y to the fifth, and I am done. Alright, let's do this one more, but let's do it really fast. See if you can follow me. I have x plus y to the sixth. That's going to be x to the sixth plus 6 x to the fifth y plus 15 x to the fourth, okay, y to the second. Remember, the powers always add up to 6 of this expansion. Okay, every one of these will add up to 6. The exponents will. Okay, and then plus. Okay, 20. Okay, x to the third, y to the third, plus 15 x to the second, y to the fourth, plus. Okay, I have 6 x y to the fifth, and then the last one is y to the sixth. Okay, this is known as a Pascal's triangle. It starts out with a, if you look at all the coefficients, it looks like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, okay, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. That's what we have. Those are the coefficients. Okay, that is Pascal's triangle. Okay, but what happens when you get something like this, x plus y to the, let's say, 100th power? Okay, you don't want to keep going and going and going and trying to expand this and taking a long time to do that. So we're going to come up with what's called a binomial theorem. And in the binomial theorem, you need to know factorials. Okay, it's actually really, really easy, but I'm going to explain what factorials are real quick if you don't know what factorials are. So here it is. We're going to play a game called factorials. Okay, we're going to set the rules up first. Okay, rule number 1: 0 factorial, is called 1. We're just going to define that. That's the way we're going to define that. 1 factorial is also 1. 2 factorial is 2 times 1, which is 2. 3 factorial means 3 times 2 times 1, which is 6. 4 factorial means 4 times 3 times 2 times 1, which is 6 times 4, really, which is 24. So on and so forth. Okay, so as we go on right there, so we say, 100 factorial, that just means 100 times 99 times 98 times 97 times 96, okay, times dot 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 dot. You keep multiplying all the way until you get to 1. That's what 100th factorial means. So let's do some simple problems with factorial. So let's say we have a 100th factorial divided by 98 factorial. Well, we can expand the 100th factorial out, okay, and do all of this, okay, or you would notice that this is really 100 times 99 times 98 factorial. I'm going to stop right there because I have a 98 factorial on the bottom, and I can cancel out, and that's going to be 9900, and that's a quick way you can reduce off factorials and get that answer. Okay, so let's do one more example with the factorials. Okay, let's say you have a 20 factorial. Okay, all that over, let's say you have a 18 factorial. Okay, times, let's say you have a 3 factorial. If I want to simplify this, what I'm going to do is on the top, I'm going to go 20 times 19 times 18 factorial. I'm going to stop right there on the top because I have 18 factorial on the bottom I can cancel out, but I also have 3 times 2 times 1. Okay, the 18 factorials cancel out. Okay, 3 will reduce this 20 into a 10, so I'm going to get 190 on the top, and I have 2 will reduce 20, excuse me, and then I have 190 on the top, and on the bottom I have a 3. And that's how you simplify factorials. Okay, having said that, and here comes the binomial theorem. Okay, it's a piece of cake. Let's say you have x plus y to the nth power. Okay, we know from Pascal's triangle, x starts out with an nth power. Okay, so then I know my x goes down by 1, so I get n minus 1, and then my y becomes power of 1. I'm going to leave a little space here for my coefficients. Okay, I'm going to write those in factorial notation. I know my next term, my x will be n minus 2, and then y will have a power of 2. And then my next term, I know my x will have power of n minus 3, my y will be power of 3, plus, okay, dot, 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 okay, and then my random term is going to have x to the, let's say y is the power of r, my n will be, my x will have a power of n minus r, okay, and plus dot, 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 and it goes on forever until the end, my y becomes the power of n. Okay, so each time my power goes down by 1 on the x, and the power comes up by 1. Now, how do I find my coefficients? That's easy. I have a little formula. It will always be n factorial on the top, and the bottom will come from these coefficients right there. Okay, that'll be n minus 1 factorial times 1 factorial. Okay, then this coefficient will be n factorial over n minus 2 factorial times 2 factorial. Okay, and then this will be n factorial on the top, and then the bottom will be n minus 3 factorial times 3 factorial. And then finally my random term is going to have n factorial, all that over n minus r factorial times r factorial. And that's it. That is the binomial theorem. Now, how can this help me expand my binomial? Let's take an example. Here's an example. Okay, let's say we have x plus y to the 100th power. And I don't want to write out the Pascal's triangle because it's going to take a long time. So I can just actually start writing out all the terms. So let me do a few of these and you'll see how easy it is. My x will be to the 100th power plus, then my x will be to the 99, my y will be the first. I'm going to leave space for coefficients to fill them in a second. Then x will be 98, my y is second. And then I have a plus, my x will be to 97, my y is third. And then I have a plus, okay, keep on going, and let's do a couple more. Okay, my x will be 96, my y is to the fourth. And then plus 2 more, let's go x to the 95, and y is to the fifth. Remember, all my powers have to add up to 100 in this problem. And then the last one will be dot 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 dot, and then last one is going to be y is to the 100th. Okay, let's fill in all the coefficients using a factorial notation, binomial theorem. Okay, this would be 100 factorial on top. This would be 99 factorial, okay, and the bottom, and a 1 factorial. And this would be 100 factorial on the top. My bottom will be 98 factorial times 2 factorial. And next one will be 100 factorial on the top, 97 factorial on the bottom, times 3 factorial. And then this will be 100 factorial on the top, and then that'll be 96 factorial times 4 factorial. And then next one will be 100 factorial on the top, all that over 95 factorial, okay, times 5 factorial. As you can see, the only thing that's left is to simplify each one of these, okay, and we can use a calculator to simplify that, but right now I'm just going to let you leave it in a factorial notation. You don't need to simplify that. Okay, one more thing I'm going to show you here. Okay, I want you to notice that I'm going to have let's say this is the first term, and that's my first term, and this is my second term. Now I want you to notice the power on the y each time. So third term, okay, fourth term. Okay, notice the power on the y on the fifth term. It's always 1 less. So in the sixth term, okay, the power on the y is 1 less. So if I randomly ask you, okay, and say I want you to find, and this is what shows up on the SAT, find, let's say, 59th term. Okay, that means I know my y is going to be 58 power because it'll be 1 less. My x will have a power of course they have to add up to 100 in this one, so x will have power of 42. And then my coefficient will be 100 factorial over 42 factorial times 58 factorial. Okay, and that will be the 59th term of this binomial expansion. So you can find any random term they're asking you to. Okay, if they ask you to find, let's say, 90th term, you can find that. It doesn't take a lot of time. Okay, so we can write in a factorial notation using binomial theorem. It's easy to find that. Okay, the other thing I want you to notice is this. Okay, if this ends up being a negative in the middle, okay, let's change that to negative. Only thing that happens is my signs alternate. So plus minus. Always start with plus. This now becomes minus. Okay. And the next one would be plus, and then one after that will be minus. Okay, we're going to alternate back and forth. Always start with plus minus, plus minus. Now, let me do an example of that. Okay. And maybe it will be a little bit more clear. Okay, let's just say I have x minus y to the 10th power, and I want to expand this using a binomial theorem. Now, you're going to have x to the 10th. Okay, that's plus, and there'll be a minus. Okay, and then this will be x to the 9th y, and then next one will be a plus, and then it'll be x to the 8th y to the 2nd, and then next time will be minus, it'll be x to the 7th and y to the 3rd, and then next one will be a plus. Okay, then you have x to the 6th and y to the 4th, and then next one will be a minus, x to the 5th and y to the 5th, and then it'll be a plus, x to the 4th and y to the 6th. Then you have a minus, x to the 3rd, y to the 7th, and then you have a plus, x to the 2nd and y to the 8th. Then you have a minus, x, y to the 9th, and then finally you have a plus, y to the 10th. Okay, see how they alternate, plus minus, plus minus. Of course, my coefficients are easy. That's 10 factorial 9 factorial times 1 factorial. And this would be 10 factorial over 8 factorial times 2 factorial. This would be 10 factorial over 7 factorial times 3 factorial. This would be 10 factorial over 6 factorial times 4 factorial. This would be 10 factorial over 5 factorial times, let's go backwards. Okay, factorial. Factorial over 5 factorial. This would be 10 factorial over 4 factorial times 6 factorial. This would be 10 factorial over 3 factorial times 7 factorial. Next one would be 10 factorial over 2 factorial times 8 factorial. Next one would be 10 factorial over 1 factorial times 9 factorial. And that's it. Okay? So they alternate plus minus. Now there's another way. If you really are lazy and don't want to switch signs back and forth, there's another way to do it. Okay, let me do that as an example. Okay, let's say you have, let's complicate our lives. Let's say you have a 2x minus 3y, and I want to expand that, let's say to 10. Okay, I can use plus on everything. Now I'm going to have this. It's going to be, now the 2x acts as the first term. So I'm going to have to put parentheses around 2x. Okay, raise that to the 10th power. I'm going to use plus for everything. Even though there's a minus in the middle, I'm going to use plus, and you'll see why I can get away with that as long as I do this. Okay, and you also see why the second term turns out to be negative. So the next term is going to be 2x to the 9th and negative 3y to the 1st. Okay, and then the next term is going to be 2x to the 8th, negative 3y to the 2nd. See, when I raise negative 3y to the 2nd, that's positive. But when I raise negative 3y to the 1st, that's going to be negative. Okay, and then I can just keep on going plus. Then I can go 2x to the 7th, negative 3y to the 3rd, then plus, I have a 2x to the 6th, and then have a negative 3y. Notice I'm putting parentheses around that. Okay, both of these terms, because I have to raise both the 2x, 2 and the x to the 6th power, and negative 3 and y to the 4th power. And then keep going. Let me finish this off. Okay, that's going to be 2x to the 5th, negative 3y to the 5th. Okay, plus I have a negative positive 2x to the 4th, and then have a negative 3y to the 6th, plus then I have a positive 2x to the 3rd, and then have a negative 3y to the 7th, plus, and I have a positive 2x to the 2nd, and then I have a negative 3y to the 8th, and then I have a plus, and then I have a positive 2x to the 1st, negative 3y to the 9th, and then I have a plus. Finally, I have a negative 3y to the 10th. Okay. I also want you to notice how many terms I have. This is 10th power. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's going to be 11 terms when I expand this because I'm raising it to 10th power. So if I raise it to 11th power, I'm going to have 12 terms. Okay. Now I also want you to notice there's also another pattern that keep repeating here. So let's put in the coefficients. It would be 10 factorial over 9 factorial times 1 factorial. This will be 10 factorial over 8 factorial times 2 factorial. Okay, and the next one will be 10 factorial, all that over 7 factorial times 3 factorial. Next one will be 10 factorial over 6 factorial times 4 factorial. Next one will be 10 factorial over 5 factorial times 5 factorial. Next one will be 10 factorial over 4 factorial times 6 factorial. Next one will be 10 factorial over 3 factorial times 7 factorial. I want you to notice something. This is same as that, and this is same as that. Okay, and what do you think the next one is going to be? Next one is going to be 10 factorial over 2 factorial times 8 factorial, which is exactly same as that term. So I'm going backwards. Okay, the next one will be 10 factorial over 1 factorial. Okay, that's 1 there, times 9 factorial, which means this is same number as this number right there. And there it is. They repeat. You get to a certain point, they repeat. If you have odd number of terms, the middle one is going to be unique, and everything to the right and left repeats. If you have even number of terms, okay, in expansion, the middle two are going to be exactly the same.